Okay, this is day 2, part 2, and the question is, how accurate will our predictions be? Suppose that I randomly selected 10 students from Hillcrest High School and recorded their weight in pounds. Okay, so there we go. If I were randomly select one more student, what would be a good prediction of his or her weight? And I would guess maybe the average weight, right, of all the other students could be a predictor of what this new student would be. So if we wanted to figure that out, we could of course add them all up and divide by 10, or I'm just showing you again, because people keep being afraid of the calculator, put your data, where'd it go? I lost one, just one moment. Excuse me, I'd lost this 103. Anyway, here's my weights. So I go to Stat, Calculate, one variable statistics. Again, the newer calculators will prompt you. The old one, you just put in that you want it to do it for list 1. And our average weight is 153.6. Okay. Of course, this prediction is not likely to be correct. Okay. I mean, it could be, but it's not using enough data to be correct. So typically, how far are our observations from the mean? In other words, how far off should we expect it to be? That is a standard deviation question. So we have S of x equals, remember this is a sample, the sum of every value minus the average value squared, and all over n minus 1, because this is a sample. And we can get this from our calculator right here, 3.96, approximately 39.6 pounds. So we would say, you know, on average they're this, but it's likely to be this off, plus or minus. That's a lot of deviation, especially when we talk about 40 pounds on somebody's weight. 40 pounds is a huge amount of weight. Okay? Is there any way to improve our prediction? In other words, is there a way I can reduce the standard deviation? Well, let me tell you a story. When you go to a carnival and walk up to the "can I guess your weight" thing, okay, the guy is looking at you. What is he taking into consideration before he guesses your weight? Hopefully you're thinking your height, your build, right? They wouldn't do it if the guy was blindfolded and you walked up and said, "Guess my weight," and all he could hear was your voice. He needs to also look at your height and other things about you to see if he can guess your weight. And they put somebody there that's skilled doing that, okay? So we've added the height. Now we think the height might help predict the weight. So the heights will actually be our x values, and our weights will be the y values. Okay, so I've gone into Stat, Edit. Now here are my weights, and here are my heights. But remember, I want these to be the x values. So I'd go to Stat, Calculate, one variable stats. Let me clear that out real quick. Stat, Calculate, one variable stats. And this time I'm going to say my x's are in list 2. And my y's are in list 1. There's no rule. You can even name these lists. I'm just too lazy. And then we'd want to go ahead and, comma, store that in Stat, Calculate, I lied, vars, y vars, function y1, go to what? I don't know. Let me pause and see what's going on. Sorry, I went ahead and did the same thing. I'd had something weird stored in my y equals, so I had to clear that out first. But here's my equation. You can see it's right there. And to save time, I have put all of this on your notes. Okay, so you can see our scatter plot. What are we missing? We're missing that this is our height, or sorry, this is our height, I before E except after C, and this is our weight. Okay, and we have a nice line of best fit. And then we're worried if maybe it's not linear. Maybe as people get taller, they don't gain as much weight or something. I don't know. So I also went ahead and did, this was from the residuals. This is y minus y hat. And here is my recid plot. And you can see that it's scattered. So it's probably okay to use a linear regression. Okay. Now, of course, the predictions using this regression line aren't perfect either. So we want to figure out how far off they are. Well, that would be the standard deviation of the residuals. Just like up here, we wanted to find out how far off our weights were. So we found the standard deviation of the weights. Okay, now let's find the standard deviation of the residuals. So this is the formula that I prefer right here. Okay. This SS recid, that's the same thing. Okay. This is the weird abbreviation for every y value minus the y hat, and then we square it just like we would normally. So it would have been taking, if we go back all the way back here, it'd be adding another column where we squared this number, right? Y minus y hat squared, just like we do a standard deviation. Either way, okay. Let's write down the formula. Let's take a side note, okay? Here's a side note. We know, just like before, standard deviation is the square root of the sum of x minus the average x squared all over n minus 1. Okay. Well, the standard deviation for the residuals, and we use E for error because residuals are a measurement of error, is the square root of the residual, y minus y hat, minus basically y hat minus y hat, everything on the thing, or the average residual. And this time we're using two variables. We're talking about two variables, x's and y's, so it's n minus 2. This y hat minus y hat, basically this is the average error, which is always, the average error is going to be equal to 0, so it could go away. Now this is just some upper level math stuff. I'm showing you a link. If it bothers you, ignore it and just think, this is how we do it. And it's really just saying the same thing as the sum of all the errors squared all over n minus 2, being that the errors are the residual. Okay, those are the errors. But this is how it comes from. It comes from the regular standard deviation formula, but it just happens to be that the average of the errors is 0, so it would go away. Okay. Another thing, this SS equals sum of squares, so SS recid is the sum of the squared residuals. S is also called the square root mean error, or the root mean square error, and S of E stands for standard deviation of errors. These are just abbreviations you need to know because AP likes to throw them in. So let's calculate the standard deviation of the residuals for this data. So let's switch. We've got S equals, okay, and it's the sum of every value minus the approximate value squared all over n minus 2, which in this case, I'm going to go to my calculator, okay. Stat, edit, I've run my line. Did I run my line? I don't know why it keeps doing that, whatever. Let's try zoom 9. No. Let me pause and fix this. Sorry, this emulator is touchy and it got confused because when I did my stat plot the second time to double check, I'd put list 1 and list 2. But remember, I had my x's in list 2 and my y's in list 1. So we're going to go to stat, edit, and this time, again, we want the residuals here. So second list, recid. There's all my y's minus my y hats. And now I want to know what they would add up to, right? Because that's the sum of all of these. So we're going to go to stat, calculate, one variable stats, and this little extra 9, we're going to do that again. Stat, calculate, one variable stats. Second, list 3 is where my residuals are. And they totaled, squared. See, it knows to square stuff. It took all our residuals, squared them, and added them up. And we got 38,000, or I lied, 3,828.9. Again, I've got that saved for you, but you need to make sure you know how to get to this. Okay, all over n minus 2. Well, there were 10 people, so we're going to divide that by 8. Which means my approximate residual, I'm going to put this down here, is 21.88 pounds. Okay, so if we just used knowing everybody else's height to guess or predict the height of a new student, we have an average error of 39 pounds. But if we use their height if we use their weight, I was talking about weight and I think I said height, but an average error of 39 pounds to guess their weight. If we use their height to help predict their weight, our error went down more than 10 pounds. We're now likely to be off just 21 pounds. Now here is the key. This is how you write this, memorize this. I will ding you for this. Okay, I'm going to make it in green for that's where the money is. It's most important. This is what you say. On average, the observed weights are, observed are the ones, these are the y hat ones, okay, are 21.88 pounds from the predicted weights. And I just screwed that up again. Sorry, the predicted weights are the y hats. And these are the observed are the actual ones. Okay, these are the actual weights. You need to memorize this formula. The formula is this. You say on average, the observed, whatever you're talking about, are your standard deviation of the residuals from the predicted, whatever you're talking about. Okay, you should now be able to do homework 3, problems page 192, 11, 12, and 45. Make sure you pay attention on number 45. You skip part B, but calculate and interpret S. And when I mean interpret S, this whole highlighted green garbage here, that's your interpretation for S. Okay, this is S. Okay, and the same thing for 49 and 50. You will need to have most of that done before class, and then we will discuss.